Hi, welcome to Dr. Pat TV. We are looking at areas between two graphs, and now we're looking at part three of this. And let's do an application here. We're looking at profits. We want to know what our profit's doing. Is our profit going up? Is our profits going down? If we change our production level from 5,600 units to 6,800 units. And the information that we have is we have two formulas here. We have a marginal cost and we have a marginal revenue. Okay, and so the other things is that marginal revenue, marginal cost are in terms of millions of dollars, and our units are thousands of units. Okay, so because they're thousands of units, if I'm going to do any of my calculations, I'm not going to type in 5600 into my formulas. I'm just going to type in 5.6 because it's thousands of units. So just got to be careful of that, making sure that we got our units covered in that way. All right, so now how do we go about solving this problem when we're looking at change of profits? Because I'm like going, well, what do I got? What do I do? The key point here is what we're looking at is the marginal. We have marginals. MC, marginal cost, MR, marginal revenue. That's the business term for rate of change of cost, rate of change of revenue. So we have the derivatives. So that's telling me if I want to find the change, the total change in profits, then basically I'm starting with the derivatives. I'm going to use the anti-derivatives. Looks like I'm going to integrate here. So that's the catch. All right, so what we're looking at here is our two graphs. I've got the graphs of marginal revenue there. That's that straight line there. And I've got the graph of marginal cost. And so for our units that we were interested in, it's 5.6 to 6.8. So we're looking at this area right here. This is the area that we want to calculate. That calculation of the area will be the change in profit. Now, one of the key points to know about this, especially when you're doing your business courses and things like this, if you have marginal revenue and it's on top as compared to your marginal cost, that means your revenue is changing more than your cost is. And that would mean that you would have more revenue coming in than cost going out. That would mean that your profit is going up. So all this area here, when marginal revenue is above the marginal cost graph, all this area here is good area for your profit. Okay, it's when we get past this intersection, when they switch perspectives and marginal cost goes above marginal revenue, we're now at a production level where our cost for each item is exceeding our revenue that we're bringing in. And so that would be a bad situation. Here's where our profit starts going down, starts decreasing. We start losing a little bit of profit there. I'm not saying that we have negative profit, that we have complete loss. I'm just saying that from this area out there, we will actually start to our profit will start coming down. It won't be as the high max. And it's a cool little relationship here mathematically. The intersection there, that is when you're going to have the maximum profit possible. So the intersection between marginal revenue and marginal cost, that is where you have your optimization of your profit. That's when you have your maximum and your minimums depending on the relationships. Okay, so be looking for those intersections. All right, so now back to our problem. We're looking for this area. So it's going to be top function minus bottom function. And since we already knew the units, our change in productions was from 5.6 thousand units to 6.8 thousand units. And so then basically those are our lower and upper limits of integration. We have the top function minus the bottom function. Marginal revenue minus marginal cost will get you marginal profit. When you integrate that, you get the change in profit. Okay, so basically kind of simplifying this negative goes all the way through. So, and then combining with that, that's where I got this expression. So this right here, this 8 plus 6q minus q squared, you could actually have a business term to that. That would be your marginal profit formula. So when you actually do the subtraction there of MR minus MC, you do have your marginal profit formula there. When we integrate it, we're going to get the change in the profit. And so we do the antiderivative of this. Nice straightforward power rule. And then we're going to substitute in 5.6, substitute 6.8, and that's what I get for these two values here. Take the difference because that's what the fundamental theorem calculus tells us to do. You plug in these two numbers and take the differences of your results. And so we got 7.968. So that's telling me my profit is going up 7 million, so almost 8 million. That's what that area represents there. A change in profit. We got an increase of profit. Why is it an increase? It's positive there because marginal revenue was above marginal cost. Once we start getting to this right side out here, when we change that perspective, we would actually start getting negative values there in the change of profit. Okay, hope this helps. That gives an idea of how we actually use a business application for the areas between two curves. Thanks, and hey, have a good day.